Hello, hi everyone. Welcome to join my section. I'm glad to meet you here virtually, just like last year. It's my pleasure to represent Red Hat to share this topic with you. Today, I'm going to share the emerging HPC trends and Red Hat AI strategy. I'm also going to cover container technologies for AI and ML workloads. And then I will cover more about why Red Hat OpenShift for AI ML. I will raise two examples here. The first one is Jupyter as a service, and the second one is GPU as a service. And then last but not least, I will share a case reference to you regarding leveraging Red Hat technology to provide a connected car. Okay, first I will share about the emerging HPC trends. Here you can see some data, some findings from Hyperion research get back to the day of 2020. The first one is talking about cloud. I know that when talking about cloud, you think about HPC cloud, particularly when get back to around 5 or even more years ago. But for the current 2 to 3 years, we will have another meaning, not just for the HPC cloud. We will think about using containers, okay, as the cloud technologies. And then maybe even in the form factor of hybrid cloud or multi-cloud. Hybrid cloud meaning that I have the on-premises for the workload, and then I can extend it or scale it through the public cloud. Multi-cloud is that I have multiple clouds. They may be work closely together or in a certain level of interoperability. So I think the norm right now is this. When talking about cloud, is definitely must include a container. And then last but not least, of course, the AI ML, because AI and ML help to drive the adoption of container. It helps the customer don't ask why container anymore, it's just how. And then the second one is talking about multiple hardware architecture. Because in the past, normally you can see around 90% of the HPC deployment are based on x86, no matter it's Intel or AMD based, with maybe a small portion running the IBM Power or SYSTEX. But right now, particularly for the past 1 to 2 years, we can see the emergence of the ARM processor. Okay, just take an example. When you remember the top 500, the top one right now is still the Japan Research Institute, talking about the Fugaku. They are using the ARM processor architecture. And I would like to also emphasize this, they are using Red Hat Enterprise Linux as their operating system. So our operating system are also supporting the multiple hardware architecture. So and then the third one is talking about the accelerator, no matter it's GPU or FPGA. From the traditional HPC to the current AI and ML, we can see it's just a norm or even becomes a must-have components in the deployment. And last but not least, we can see also, because in the past, it's very common to see HPC workload is deployed for the research purposes mainly. But right now we can see the enterprise usage, for example, like the oil and gas, like the gaming industry, or even for the telco, they right now is leveraged more and more for the HPC technology to do business related initiative. So what Red Hat is doing regarding for HPC, example one is here. You can see we have different articles published, no matter from our own technology, for example like Portland, for example like container platform, or we also have engagement with the Worldwide Research Institute. In here you can see the LLNL and even the IBM. Right, this is just one of the example. So we are still active in this area. And the second example is just mentioned about the top 500, or even for the Green 500, we also have footprint of Red Hat or using our own technology. For the top 3 of top 500, namely the Fugaku in Japan and Sierra and Summit, they're also powered by IBM. They are all based on Red Hat operating system. We call it Enterprise Linux. So you can see we have footprint everywhere. For the HPC related, actually, Red Hat also initiated with different projects, with different parties or research institute. One example is called the ECP. We call it Exascale Computing Project. We work with the Sandia National Labs and then to develop the container platform for the exascale system based on Podman and also UBI. I hope that you know very well for what is Podman and UBI. In case not, perhaps I can give you some ideas. Podman actually, for example, like the it's a two works combined together. It's pod and also the manager. Podman is a tool for managing containers and images. Volumes mounted in those containers and pods made from groups of containers. UBI, as the name implies, is the universal base images. Actually, it's the base images for your runtime for your container application. It is a secure and we call it the performance-wise base images. I have another slide talking about this. And the second one is talking about scheduler integration. Actually, under the MOU, researcher as LLNL, we call the Lawrence Livermore National Laboratory, and also including IBM and Red Hat, will aim to enable next generation workload by integrating LLNL flash scheduling framework with Red Hat OpenShift to allow more traditional high-performance computing jobs to take advantage of cloud and container technologies. And the third example and the third project is talking about is we understand that we have different requirements in HPC or AI/ML for interconnector and also for the storage. Let's say for the storage we need parallel file system, so that's the reason why we commonly see Luxter and BGFS, for example, in the architecture as one of the core components. And for interconnect, we can see Infinite Bank, right? So we understand that. So we just not simply put a commercialized enterprise-grade container platform into the HPC workload, but we also try to modify it to make it run well. So that's the reason we also demonstrate through a typical workload. Let's say for the life science, we use the GROMAX, and then how we can run it on the OpenShift and then leverage the enterprise-grade function and feature, but it can run well on a HPC environment. Red Hat AI ecosystem strategy, very simple. Two keywords: partnership and also building the ecosystem. Okay, so we cannot make it happen alone. So we leverage our own technology, run the open source, run the community, and then work with different partners to make it happen. So we leverage the emerging technology like the containers, Kubernetes, DevOps inside OpenShift to accelerate the AI/ML projects. And we also provide the Open Data Hub project, okay, as a 100% open source, to provide as a blueprint, as a reference architecture to build your own AI/ML workload, rather than to build your own platform. If you would not like to build your own, you just simply want to leverage the existing one, for example, delivered by the public cloud provider. We have another solution for you. Actually, it's called the OpenShift Data Science. It is a fully supported sandbox for data scientists to quickly, for them to develop, train, and also for test their ML models. In fact, we also promote with our AI ecosystem the breadth and depth for this kind of the workload. Red Hat also in on our own dog foot, meaning that we also leverage AI and ML technology in our own business. For example, like the sales and also financial forecasting, like the customer segmentation, and also prospect of the prioritization. We also do some sort of the employee sentiment and also performance management, okay, for our customer through the Red Hat Insight. So no matter inside or outside Red Hat, we also leverage this kind of technology to gain the benefit. Talking about ecosystem, here is a picture for the ecosystem. It categorized into different areas, so we can see some of the familiar names, no matter, for example, like the infrastructure providers and also the data analytics provider. But what exactly make our ecosystem different than the other solution provider they are providing the commercial offering? I think I can share it more. You're gonna use is open source is a brand brighter, so we can see just like, for example, AI and ML lifecycle, you can see different names which is arrived on the open source, right? And also for the security and data governance, we also have different kinds of tools. We try to make it become a comprehensive offering by combining the solution provider from the market and also leverage heavily for the open source to make the success. Just now I mentioned about the Open Data Hub. I mentioned this is a blueprint. It is a reference architecture. By leveraging it, you can build your own AI and ML platform. So you can see different names in here. And last but not least, of course, you can just mention about the OpenShift with also different open source tools like the Spark and also like the Kafka for the event streaming. Open Data Hub is a reference architecture I just mentioned, right? No doubt. It's based on the open source community projects that helps demonstrate value of Red Hat portfolio and open source technology to accelerate the AI/ML lifecycle. Within the platform, data scientists can create models using Jupyter notebooks and select from popular tools like the Apache Spark for developing models. While the data science normally ends when the model is built and validated, it's still important to monitor model, right? Because this is the model life cycle to make sure that it stay healthy. That's the reason you can see Prometheus, which is another tool available in Open Data Hub, forwards the data to Grafana so data scientists can build dashboard to keep an eye on the model's health and performance. We just mentioned about the build, the own architecture. How about I just want to leverage, I just want to use it? It's the answer for you is OpenShift data science. So you can see very similar than the previous one because we also leverage our partner ecosystem, leverage the open source, but it's a managed service offering. It's run on the AWS at this moment. Okay, so Red Hat OpenShift Data Science actually is a sandbox for data scientists to experiment and discover new ways of bringing insight into the business. It is a fully managed cloud service that allows data scientists to build intelligent applications. And the teams get access to advanced ML tools delivered in an integrated experience. Data scientists can use their familiar tools or tap into a growing technology partner ecosystem for deeper AI/ML expertise without being tied to a prescriptive tool chain. I think this is very important. When teams work on a shared platform, everyone wins. Data scientists collaborate in real time in Jupyter notebooks. Developers integrate container-ready models into intelligent apps with less friction. And IT worries less about governance because this is a full bundle managed service offering. And the Red Hat Data Science connects every step of the ML lifecycle with deeper AI capabilities through its software partner ecosystem, offering a wider range of certified tools with specialty of AI/ML expertise. Deploy exploratory models to hybrid cloud and get the flexibility of running workloads wherever you need them with no commercial cloud login. I think, this is the purpose of why we are offering different offering to our customer. Let's switch to another topic I just mentioned about, right, what Red Hat was doing regarding for the HPC and AI/ML. We have different articles, different contribution. And then we talk about right now container technologies for AI/ML. I think as the diagram implies, with containers and Kubernetes, data scientists get the agility, flexibility, and portability to train, test, and deploy ML models into production quickly, and then bring the benefit showing in the right hand side, like for example, the valuable investment, accelerate the ML workflows, and also to streamline the application development. When talk about container, I understand that you must think about Docker, right? Actually, Red Hat strategy direction is moving to open source, as you know. Community-driven projects which support OCI-based Docker compliance containers. Okay, because as many of you know, Docker 1.13 was the last version of a community-driven project. We call it a Docker. And the upstream Mobi project is not geared toward releasing just a container engine and CLI like Docker project was. The redistribution of Docker CE and EE fall under different rules than the original upstream project. So that's the reason Red Hat has decided that Docker 1.13 will be the last supported version and then move away from Docker. Customers will continue to be able to use containers built with Docker, build new Docker compatible containers, and interact with Docker-based services. So it's still OCI compliant. We based on the CRI-O and based on the free tools listed here, the Podman, the Scopio, and also the Builder. And you can see the description of each of the tools at the right hand side here. But let me take some time to try to share regarding more what exactly is Podman and Builder. Podman actually is included with Red Hat Enterprise Linux 7 and X, which is daemonnets and rootlets. So it somehow addresses the pain point of Docker. It provides a familiar command line experience compatible with the Docker CLI. And you can be routed into existing infrastructure where the Docker daemon or CLI are used today. Just like you just create an alias, is the Docker is somehow equal to the Podman, and then you can leverage the Docker CLI just like what you did before. And then it does not require Kubernetes, and of course you can use Kubernetes, you can run it on OpenShift, but it is not necessary. It only needs a container host platform with compatible OS, just like the Red Hat Enterprise Linux. And then for the builder, actually is help you to create new container images, no matter it's update, modify, or something like that. It creates the OCI container image compatible with the Docker format. It has a multiple stage build supported with and without Docker files. So no matter you're familiar with the existing Docker files format, you can use it. Or you would like to build from scratch, you can use without Docker files. And then it support customizable image layer caching through the user space enablement. And it also supports unprivileged non-root container builds. UBI stands for Universal Base Image. Actually, it's a free, usable, and redistributable. We would like to leverage it as the base, as the name implies, as the base image for your application and runtime inside the container. UBI actually are OCI compliant. This is very important. Freely redistributable. This is also very important because Linux, Enterprise Linux, Red Hat Enterprise Linux is not redistributable without an entitlement. But UBI, based on Enterprise Linux, it is redistributable. Okay, it is a container-based operating system. Okay, say the one again. That include complementary runtime languages and packages. So it includes three things, not just the base images, but also the runtime language and also the RPM packages. Okay, three parts. They are built from the portions of Enterprise Linux UBI and designed to be a foundation for cloud-native and web applications. Okay, use cases developed in containers. You can build a containers application using UBI, push it to your choice of registry server, easily share with others. And because it's freely redistributable, even deployed in non-Red Hat platforms. Okay, but deployed in Red Hat platform, you can get support. Okay, but even and also not just on support, but also provide performance, security, and life cycle. Okay, this is the value that Red Hat can deliver to you. And since it is built on Enterprise Linux, UBS as a platform, this is reliable. And I just mentioned it consists of the three parts. Okay, so base images, runtime languages, and also the RPM packages. So we move away from Docker to CRI-O. This is also OCI compliant. CRO, of course, so the CRI-O is an implementation of the Kubernetes CLI We call it a container runtime interface. It actually is just a pub interface that gives the kubelab the ability to use different OCI compliant container runtimes without needing to recompile kernels. This is very important. You don't need to recompile kernels before you can use it. CRAO is a lightweight OCI compliant container runtime designed for Kubernetes, and it runs on any OCI compliant Docker compatible container images. So it's versatile, it is compatible, and it focuses on stability and lifecycle with Red Hat Core OS in OpenShift container platform. Core OS also leverage on Red Hat Enterprise Linux, but it's just immutable, it's just read-only, it's just designed for container. And CRAO improves container security and performance at scale. Okay, so container and technologies for AI and ML, and then we switch to another topic is why we need to use OpenShift for this kind of initiative. The short answer is here. OpenShift is an industry-leading Kubernetes-based container platform to provide self-service, seamless experience for data scientists to accelerate machine learning workloads. OpenShift is powered by Kubernetes operators. Actually, we call it the operators framework, enabling data scientists to easily deploy and use ML tools that empower them to create and share ML modeling, result in a consistent ML with peers and software developers without dependency on IT to provision infrastructure. So this is the short answer. We provide you everything you need in a secure and performant way. Okay, later on I will try to elaborate more. We understand what data scientists is doing. We understand their pain point. We understand what they're asking for. They don't want to spend too much time on preparing the data. They would like to stay focused on this business by developing, testing, and also try to do the life cycle of the model. So that's the reason that we need something to help them. Like, for example, they need a self-service portal. They can sharing the resources, they can access the toolset, and then they can access the accelerator, for example, like the GPU. And then they can cooperate with their teammates, with the other data scientists through the model serving and model, no matter it's building or inferencing, and then they can put the result into the application by off the workload to the application developer. And then the developer can leverage the platform also through the self-service, put the model that normally can understand by the data scientist into the application, no matter full function or features, and then to provide the business insight to bring value to the business. We understand that this is what's the asking of the data scientist, but the reality is here. Even though we understand most of the company, they will leverage open source to build their own, initially at least, no matter working with the public cloud provider or leverage their own internal skill set. But you can see in here, actually it involves quite a lot of tool sets and skill set and time, and actually it is error prone. So that's the reason they don't want to do that, but they still want to leverage the beauty of open source, the flexibility of open source. And that's the reason I just mentioned why we need a container platform that can address the pain point I just mentioned above. OpenShift is the answer for them. Actually, OpenShift is just not a piece of software. It rides on different architecture, no matter it's bare metal, running on virtual machines, or even on different public cloud offerings. And then leverage our mature operating system, okay, which is the Enterprise Linux, and then derive a tailor-made operating system for container, which is the CentOS. And then underneath, we have the Kubernetes orchestration layer, and then we also tie with the infrastructure component, meaning like the compute storage, imaging, registry, and also logging metrics, all the infrastructure stuff, okay, into the platform, and also including the operators required, like the monitoring, okay, like the lifecycle upgrade, and also the developer toolsets, the developer environment. They are also the runtime through the middleware. We combine it together as a single platform. We call it OpenShift Container Platform. And recently, we also try to enlarge and enrich our platform by adding multi-cluster support, by adding container security, no matter from build, from deploy, or from run, the whole lifecycle security toolchain, and also include the enterprise grade, the image repository. So we call that the OpenShift Plus. OpenShift Plus has 3 more components, which is we call it the advanced cluster management, provide the multi-cluster visibility, policy enforcement, application deployment, etc. And security is the advanced cluster security, which rely on our acquisition of StackRox, and then we rebrand it, and then to make it open source, okay, and support different container platform, not just on OpenShift, but all the CNCF compliant. So you can also leverage our advanced cluster security to manage the public cloud Kubernetes, meaning the XKS. Okay, and Cray is our registry enterprise grade, multi-site, robust, and then with the container security included as well. OpenShift I just mentioned, okay, it's just not a simple tool, okay, but a suite of offering. Why is it related to AI ML? I just mentioned in the very beginning for the agenda. The first one is talking about the Jupyter as a service. I think every data scientist, they are using Jupyter, no doubt. But how we can use it in a team collaboration way, it may create some kind of challenges. Because getting the Jupyter notebook software installed on your own laptop isn't too difficult. Actually, it's quite easy. But working in a local environment can be limiting. Team of data scientists and developers, how they can share and collaborate in the same environment, if there's any, which is quite difficult because it's manual and error-prone and time-consuming. Access to the limited non-shared resources means modeling takes long time or can't achieve desired accuracy. So we know that, okay, usually the data scientists start with using their matball and then based on a sample of data to derive their own modeling. But at the end of the day, they would like to test it in a much larger data set. They would like to contribute or share or collaborate their models with peers. So that's the reason they need to have a collaborative way of working. And delivering the model into production is also another challenge. So how we can do the whole life cycle of the ML modeling in a single platform is the solution. That's the reason we can leverage OpenShift Container Platform to offer the Jupyter as a service. So no matter all the self-service, no matter the data access, no matter the model testing and iteration, no matter the model sharing, and also for the life cycle, we can leverage the same platform to make it happen. And of course, it supports multi-tenancy. So no matter you would like to provide just like, or I can develop, okay, I can do it in my own MacBook, I would like to leverage it to provide the same, meaning that I would like to have this kind of isolation. I want to share, but at the same time, I still want to isolate, no matter for the project isolate or resource isolate, through identity and role-based access control, so it can be realized in the same OpenShift platform. And for the GPU, the accelerator, actually Red Hat and NVIDIA are close partner in here. So we can offer GPU as a service. Red Hat and NVIDIA are partnering to enabling the latest technological innovation for our customer. Organization can use NVIDIA NGC software hub to access GPU optimized deep learning and machine learning applications and pre-train the AI models to take advantage of massive parallel processing capabilities. Leading server providers offer NGC-ready validated servers powered by NVIDIA GPU, which are optimized to run software from NGC. Red Hat joined the NVIDIA DGX Ready software program, to offer OpenShift as a foundation for ecosystem innovation. Customers will have access to proven, tested, enterprise-grade software solutions certified with OpenShift on cluster of DGX system. So no matter you want to do the model training, we can help you through the GPU operator. Okay, delivered actually is a framework delivered from the OpenShift. It helps simplify and accelerate the compute-intensive ML/DL modeling tasks for data scientists and inferencing tasks across data centers, edge, and public clouds. The GPU operator enables OpenShift to schedule workloads that require use of GPU as equally as one would schedule CPU and memory for traditional workloads. So model training is this. The inferencing is also the same. We leverage the same architecture, leverage the same component, the same accelerator to achieve the same purpose. Here, I would like to share with you our global customer use case. The customer is BMW. They leverage our platform, they leverage our partner ecosystem, they leverage our open source technology to provide connected drive. I think you are familiar with connected drive because in the automobile industry, for example, like Tesla, they are competing with traditional car companies. Okay, and then differentiate the car provider, just like BMW. They would like to offer the connected drive to provide personalized experience. And then this kind of digital services are becoming more and more important. BMW Connected Drive enhances the ultimate driving machine with a digital service experience. This kind of experience actually is through data analysis, collecting all the sensor data in the car to understand, let's say for example, the status of the car in regarding the different components and the driver driving behaviors and also the road situation. We combine it and then we try to provide the idea. Okay, right? For example, like the enhances the driving experience. It lets the driver find and navigate to a restaurant, for example. Okay, and then use a concierge service to make a dinner reservation. Once the car driver leaves the car but forgot to close the window, okay, the mobile apps will be alerted the driver, okay, and tells them that okay, you need to close the window before you left. This is also another example of the personalized experience. With the connected drive mobile app, you can remotely start your car and even heat it up when it's cold outside. The connected drive background, actually the backend runs entirely on OpenShift and processes over 1 billion of such kind of service requests per week. And inside there is actually 12,000 of containers today. BMW builds data lake not just on-prem, okay, but also in the public cloud because all the sensors data, they are on the road, so it better make sense to build it on the road through the public cloud and then collect and then analyze it to provide insight to the driver and also provide to the car manufacturer. So this is, I think, is very interesting customer example. They are not just using it for the connected car. Instead, BMW also leverage Red Hat technology and our partner technology to provide the driverness. This kind of the initiative. This is also a very common initiative for every car manufacturer. Okay, last one I would like to summarize what I covered. When I just talk about the Red Hat AI strategy and also share with you some of the marketing trends and then take the container technology as an example why it is so common, why so actually is a core component in the workload deployment, and also demonstrate why OpenShift is the best choice for your container technologies through the example of Jupyter as a service and GPU as a service. And then share with you the BMW connected drive case sharing. So we understand that the value of AI and ML bring to every business, but we also at the same time understand that it has lots of challenges. And there's a reason Red Hat and our partner and the open source is here to help you to overcome these challenges. Okay, hope you enjoy my section and understand more about Red Hat strategies, solutions, and value proposition for HPC, AI, and ML. If you still want to know more, please engage our sales representatives in your local region or reach out to us through the event organizer. Thanks for your time. Hope to see you soon. Bye bye.